Welcome back, everyone! Today we're going to have a workshop on solving systems of linear equations. This topic has three objectives. The first objective is I can solve systems of two linear equations with two variables by graphing. Now let us begin. So you have this example. It says graph f of x equals 5 minus 2x and g sub x equals negative 2x plus 1. And the question is, how many times do the two graphs intersect? In this case, we are just going to use Desmos and we are going to graph them. So I had plugged in the two functions. F of x can be represented by variable y and g of x can also be represented by variable y. And as you can see, the two lines will not intersect. So how many times will they intersect? The answer should be they will intersect 0 times, or they will never intersect because the lines are parallel. So let us just have a quick review of what we have discussed earlier. You know that the two lines are parallel if they have the same slope but different y-intercepts. And let's look at this. The slope of this one is negative 2. The slope is the coefficient of x. Right here, the slope is also negative 2. Again, it is the coefficient of x. So you know that they have the same slope. And then look at 5 and positive 1. These are two different y-intercepts. So in that case, you have parallel lines and your lines will never intersect. Because they don't intersect, then they don't have a solution. Because you know that the solution means the intersection of the two lines. Example number 2. Given this system of equations, which of the following graphs shows the solution? What we're going to do here is we're going to plug in your functions on Desmos. So this is how your function number 1 looks like, and that is your line. Now we're going to open another window and we're going to plug in your function number 2. After plugging in your function number 2, you can tell that your answer here is letter C because your solution is on quadrant 4. This one, A is on quadrant 1, B is on quadrant 2, D is on the axis, and it is letter C that has that solution and the same line. Now let us go to example number 3. Examine the graph below. Which of the following equations could be added to the graph to create a system with a solution of 1, negative 1? Let us identify where that point is first. So 1, negative 1 is right here. So you want your line to intersect this point of this graph. What we're going to do is to plug in all these answer choices on Desmos to be able to identify which line will go through that point. Okay, I had plugged in choice A, which is y equals x minus 1, which gave me this, and as you can see, it didn't go through this point. This is the point that we wanted to go through. So that is not the right line. We're just going to turn this off. We are not going to delete it. So I'm just going to turn that off and open up another window and plug in choice B. So I had plugged in choice B, y equals negative 2x minus 1. I believe that that is a typo. So minus 1, and it didn't give me this point. So once again, this is the point that we want. So therefore, it is not letter B. I'm just turning it off and plugging in choice C. There you go. I had plugged in y equals x minus 2, which is letter C, and it went through that point. So this is the answer. We now go to objective 2. I can solve systems of two linear equations with two variables by substitution. Please understand that this is a workshop. Therefore, I'm not going to go into the full length of discussing how it is to solve variables doing substitution because that is actually discussed in another video. What we're going to do here is we're going to use all our resources to be able to go about this objective. In that case, we are going to use mostly technology. Okay? So let us now have the first example. The set of equations x plus 2y equals 4 and 2x plus 4y equals 10 has blank solutions. So once again, we're going to use Desmos on this one. Now, because some graphing calculators are only permitting you to plug in equations that are in slope-intercept form, I'm going to real quickly discuss with you how to change this to slope-intercept form. Slope-intercept form is y equals mx plus b. And so therefore we are going to isolate your y. So in this case, you put your equal sign first. That will separate your left and right. So on the left, you're going to keep your 2y. The x goes to the other side, which then will change the sign. And then the 4 stays there, so that is going to stay as positive 4. And you're going to, because you want to isolate the y, then you will divide everything by 2. I like doing it this way because I just want to make sure that I see my slope clearly, and that is also good practice for some of you that are just starting off in doing this. So now this can be plugged already, where your slope is negative 1/2 and your y-intercept is at 2, because 4 divided by 2 is 2. However, Desmos, I think, permits for us to plug this in. If in case Desmos will not permit, because they're doing, some updates also, if Desmos will no longer permit us to plug in the function in standard form, then yeah, go ahead and isolate your y, change it to slope-intercept form. So that's for that function. Let us now go to this one. So equal sign. 4, I apologize for this, guys. Okay, 4y stays there, negative 2 goes to the other side, negative 2x, and then positive 10 stays there. Okay. Okay. And then you divide them by 4, all of them by 4. Okay. And so that means that for, in this case, your y is negative 1/2, because 2 over 4, and then plus, so that was a 10, this is a 4, that's divisible by 2, so that is 5 out of 2. Alright, so I can tell by examination that they have the same slope but different y-intercepts. So these are parallel lines. If they're parallel lines, then I assume that the answer is no solution. So I had plugged it in the function the way I see it here, which is in standard form. The version of Desmos that I am using permits me to plug in the function in standard form. So x plus 2y equals 4 is plugged in. However, just to emphasize, this function that we have generated and turned into slope-intercept form, if you plug that in here, we should get the same exact line, because those two are one and the same. Alright, so let's now go to function number 2. We're going to plug that in here as well. Okay, so here you go. After plugging in function number 2, we were able to confirm our assumption that the two are parallel lines, and therefore, because they're parallel lines, they have no solution, because once again, the word solution means the intersection point of the two lines. Let us now go to example number 3. The following system of equations intersects at one point. What is the y-coordinate of this point? So we are going to now use Desmos and plug them in one by one. So I have now plugged in equation number 1 here, and we're going to open up another window. So once again, I'm going to plug this in as is. However, if your graphing calculator does not permit for you to plug in an equation in standard form, go ahead and isolate your y and change it to slope-intercept form, like what we did on that previous example. So I now have the two functions here graphed, and this is your solution. According to the question, it's asking you for the y-coordinate of this point. And so the y-coordinate of this point is negative 1.25. We're going to do the process of elimination here, and therefore it's either A or B. This is a whole number. So this is your answer. Using the technology to confirm that, I wrote here I typed here negative 5 out of 4. And that is going to give you a negative 1.25. So the answer here is B. Okay, so correction. This is example 3. That other one was example 2. Okay, still on objective 2, solve for x. Guys, the same thing. Plug this in on Desmos. You're going to get the intersection point. Choose the x coordinate. So let's do that. So I had plugged in equation 1, and you're going to open up another window to plug in equation 2. Okay, so here is your intersection point, which is your solution, and the answer is -3. So we're now on objective 3. I can solve systems of 2 linear equations with 2 variables by elimination. So when using elimination to solve, what is a possible first step? Elimination is a process that can be used whenever your x or y coefficients have the same numbers or the same values. And for you to do that, let's say you want to eliminate the x, you want to make this 3 and 4 be the same. And for you to be able to do that, then I will have to multiply 3 by 4. And I will have to multiply 4 by 3, making them become a 12. So, but then whatever you do on this term will have to be applied to all the terms. So if you multiply this by 4, you will multiply all these by 4. If you multiply this by 3, you will multiply all these by 3. Guys, please understand, this discussion I'm giving you is in a full-length video wherein you're solving by the process of elimination. Check out that video. This is just a workshop, so I assume that you already have previous knowledge on this one, so which is why this is going to be fast and quick. So anyways, that is what you will do to x if you want to eliminate the x. However, if you look at this, the best thing to do here is to eliminate the y. Why is that so? You see the 4 and you see the 2. This is so easy. I will just have to multiply all these terms by 2 in order for this to become a 4. Once I make this become a 4, it's so easy for me to add. Why add? Because the signs are different. So for when you add different signs, you turn to subtraction, which will get this to become 0 once this becomes a 4. So let's take a look at that. Looking at that right now, I see D. If I multiply that second function all by 2's, this will turn to a 4. Therefore, I can now just easily eliminate this if I add. Okay, so the answer here is D. Alright, let us now go to the next example. It says solve the following systems of equation for x using elimination. Okay, I know it says elimination on this one, guys, but we are doing a workshop. Because we're doing a workshop, we want to use all the technology that is afforded to us. In this case, Desmos. We're going to, for me to assess you on how you do the process of elimination, that is going to be done in the checkpoints. Okay, so for the first function, I now have this line. You will open up another window and plug in the next line. Okay, so here are your functions, and this intersection point right here is your solution. It says on the question for you to get the x value. That means that between x and y here, -3 and -4, your answer should be the x value, which is -3. So that is the end of our workshop. I hope that you have learned a lot, and good luck in taking your power focus assessment on solving systems of linear equations.